to discuss some of what you've heard. Now, what I want to add on here is, as Gabor said, this stuff is happening. And I want to talk about the industrial metaverse, the world I live in. Now, it was about almost 18 months ago, Areti and the team from Inlet Europe asked me to say, hey, we're doing this Inspire TEDx talk. Can you do something on some cool stuff? And I said, I will. I'll do the energy metaverse, because we're building it already. I work a lot with Siemens, with Cedric Nika and his team. And I was like, hey, you keep talking about real meets digital. What are you doing with the industrial metaverse? And my logic 18 months ago was that if you start thinking about the metaverse, and I walk into energy companies and I go, what are you doing in the metaverse? I'm talking to someone in marketing. And they're going, oh yeah, there's these metaversey thingies. We need a presence in there. You just heard Gabor give an excellent session in terms of some of the stuff you need to think about. And what do I mean by why do I need a presence? Hey, all the cool kids are playing Fortnite. I play a lot of Fortnite. I'm a middle-aged white guy, right? I'm odd. But I play a lot of Fortnite. I watched the Ari Grande concert live in Fortnite. I'm not an Ari Grande fan. I want to see what it's like. I have 15 different avatars at last count in various programs. So I try out all this stuff. I've been using AR and VR for about 10 years. And I was going to companies going, so you want a presence in the metaverse? Fine. So where are you going to put your logo? Is it in Roblox? Is it in the Lego? Are you going to create your own? Are you going to buy land in the Decentraland? You're going to have jumpers with your logo on it and do guerrilla marketing at someone else's event. So that was one thing. Second one was the HR guys were saying, yeah, but we want to be cool kids as well, because we need to be seen as cool. So we need to start using the latest technology, because we in the industry have a serious problem hiring cool kids. They all want to go somewhere else. So we want to start using VR for collaboration. We're all in lockdown, we're bored tears. And they all saw what Accenture did. Do you know that Accenture bought 60,000 VR headsets and sent them out to their new employees, and they had virtual team meetings in Altspace? They called it the nth floor for 30 minutes a week to build teams in the pandemic. Done. So then I started talking to the folks that do the real work. They said, well, we design buildings, we design power plants, we build the next wind turbine. We do it all in CAD systems. We create a digital twin before we build anything. I talked to the operations guys, and they're saying, yeah, during the pandemic, we couldn't send out engineers. We started using augmented reality so that when the only person in the room was the smartest person in the room, they could get information on what to do, whatever. So augmented reality is being used today. And then you have all the thing with when we roll out all of the new wind turbines and the systems, and we instrument everything. We put IoT on everything. We get all the real-time data back. We have a digital twin representing what's happening in the real world. Right? All happening today. And then someone says, well, we need to train the workers because we're changing the layout of the factory, and we want to train the workers on the new workspace and what they do. We'll do it in VR before we build the thing, because if we build it, we take 3 weeks to train them. We're in production 3+ weeks. If we're building it, we train them in VR. The minute the factory goes live, we've saved 3 weeks. All of this stuff is happening. So I was going, we're doing this already, bits of it. So what's different? They were all siloed applications. And then along comes Unreal, the engine that runs a lot of the games, Unity, NVIDIA. And what did Siemens and NVIDIA announce in June? The industrial metaverse. And what they're looking to do is to take the fundamental building block, which is a digital twin, a digital representation of something in the real world, but instead of having one that we designed from, one that we use to train people in, one that we use to get the real-time information, they were all separate. And what they're going to do is they're going to put them all into one digital version of the truth. Now, I look at the metaverse. I don't know what the industrial metaverse or the metaverse or whatever is going to end up to be. I don't. If I did, I'd be off making billions. I don't. I don't even know if we'll call it the metaverse. But what I do know is that in my world, in industry, the fundamental building block of this is the digital twin. And what is the digital twin? It is simply the next evolution of digitalization. And in that digital twin, you will have, Gabor mentioned it, you will have experiences. Now that experience may be on a two-dimensional screen, but because it is a 3D model, you potentially can use AR or augmented reality glasses, you can use virtual reality, or the new buzzword is XR. It's extended reality. It's a bit of both. And whatever Apple, assuming they do bring out something, and if they democratize AR and VR and immersive experiences, off we go. The horse has left. So my thing to energy companies is that if you think, Kev, you're smoking something, you're away with the fairies, as they'd say where I come from. It's like, no, we're doing this already. In every company, you're doing bits of this. And where Siemens and the likes of NVIDIA and Bentley Systems and SolidWorks are all working. Today, if you go with Siemens and they say, I build a new factory, they design the entire factory, the conveyor belts, the software that runs the robots, everything in software, in a 2D model, before anybody puts a spade in the ground. It's called virtual commissioning. The finance guys signed it off, the engineering team signed it off, the building contractor signs it off. Done. And what they're now going to do with NVIDIA is they're saying, well, we've got the digital twin. Now we build it, we get all the real-time information, so I can do all the predictive maintenance and whatever. It's a digital twin on steroids. And you know what I'm going to do? I'm going to simulate. What happens if I turn up the speed of the conveyor belt by 20%? Will there be any bottleneck on the production line, like the BMW factory? BMW have done this. They simulate, because what they're doing is they are simulating the real world in a 3D virtual world that allows a spatial experience in real time, and you can simulate endless possibilities. Because where NVIDIA and them are headed for is they go, we need to train the AI, the artificial intelligence that runs the robot that drives the car. How do we do that today? We build a robot and we let him run around the factory floor. And the robot trains himself. So if he crashes into my legs, that's a training experience for him. It's something else for me, but he learned. So what do? You create a photorealistic digital twin of the factory. You run it in real time. Actually, you run it in faster than real time, and you train the AI because the AI thinks it's in the real world. And all of the technology for a photorealistic simulated world is coming from the gaming industry, coming from the physics engines, from all the industrial companies, and it's just all coming together. And you might think I'm smoking dope, but I'm telling you that's what's going on. There are multiple companies out there today training robots for doing inspections of transmission lines. How do you train the robot? Well, sorry, how do you, it's not you train the drone. You need lots of photos. How do I detect corrosion? You need different photos in different weather conditions. So it could take you years to get enough photos to train the AI. What do? You simulate that in a photorealistic game engine, Unreal, Unity, Omniverse from NVIDIA, and you take 1 billion photos in different weather conditions, different lighting conditions, and you train the AI in about 1,000th of the time. That's done today. Now, you think it's all done. There's a lot of features, right? I like features. So if you want to simulate a car traveling at 100 kilometers an hour in real time in terms of the dynamics of the wind flow over that car, right? Today, that cannot be done. If you had access to the greatest supercomputer on Earth, it does not have enough computational power to do that in real time. So why are Intel and NVIDIA and AMD and ARM and everybody continuing down the path of new processing, new architectures for the technology that will drive all of this? That's why. So there are huge barriers to this. And I'm a technology guy, the art of the possible. And then we'll have to figure out, will people accept it? And then I don't know. As people that know me well, I go, hey, technology is the easy bit. It's when those people get involved, it gets complicated. But if anybody thinks this is not happening, look, I disagree with you. This is happening. That's my spiel. With that, I'd like to welcome Dr. Frederick Larson on stage with his panel. As they talk about this as normal people, not like someone like me, and figure out what does this mean for business, and it'll be an interactive session. Frederick?